Finally, it's done. RetroGo full build tutorial. Hello everyone, welcome back to another episode of DSN Industries YouTube channel. Today I will introduce a RetroGo ecosystem. When episode is over, you can easily make your own handheld game console. Before we dive into episode, like and share this video. Also subscribe to channel for community growth. This keep me motivated. Let's start to build. I can show you every detail step by step. Also, this tutorial easiest way to build RetroGo console. But before we start, why I didn't make a own custom version? There is a lot of reason. Firstly, RetroGo ecosystem supported up to ESP-IDF version of 5.2, but much compatible for version 4.4. Today, we can't reach directly this version on installer. Even that I use this version, ecosystem not usable with IDF directly. You need to do a lot of step and customization. There people make many mistakes in this section. Further I can't answer all questions. However, so I use already prepared file for the flash AMD board. Let's look what component I used. ESP32-S3 16R8 dev kit, MAX98357A display, SD card and card reader. I use built-in display, MAX98357A I2S audio amplifier and speaker, 10 tactile button, 2 5K resistor, 2 10K resistor, 200K resistor for battery indicator. For prototyping, breadboard and jumper cables. Continue with wiring. Unfortunately, we can't any change in here. Before I talk, I use already prepared image for making hardware. You can follow this setup for making hardware. Let me explain. First step, display wiring. You have noticed MISO pin leave and empty. Also, CS pin goes to ground. This setup didn't use that. Other pins goes exactly where Sam is seen. Next step, SD card reader. I use built-in display. This means we need to connect only 4 cables. But if you are using SD card reader like this and it has MS voltage regulator, in that must be connect VCC pin goes to 5V directly. Display and SD card uses SPI communication but separated and different SPI buses. Next step, I2S audio amplifier. BLCK pins goes to GPIO 41. LRC pin goes to GPIO 42. Data in pins goes to GPIO 40. Gain pins uses for amplifier volume boost up. You can follow this table to choose correct you want. I leave it empty. SD pins goes to 3.3V. Must be careful that you can't connect to the 5V. Ground to ground. Voltage input goes to 5V, 3.3V, or you can connect directly battery positive leg. Also you can use up to 3W for home speaker. Next step, battery indicator. You needed to use a voltage divider for don't want to harm your dev board. LiPo battery given maximum 4.2V. That means this can be damage your board. You can use exactly same schematic for do that. Serial connection to 2 resistor. Top is going to battery positive, bottom going to battery negative. Middle output is a signal, also goes to GPIO 4 for analog battery measurement. Lastly, controlling. In this scenario, we are use GPIO for connecting to button. We have already enough free GPIO for doing this job, but controller separated to 2 parts. One of them digital read with GPIO and the other part analog read with GPIO for direction buttons. Disadvantage to use two less GPIO for make a controller. In gamepad, GPIO map buttons, one leg goes to GPIO and the other leg is go to ground. Cause of that, pin already set input flap. When in gamepad ADC map part, something changed in here. I made power line with using two 5.1K resistor. This given to us fixed voltage output for reading analog read. I see inconsistent between two values when I look to picture. If I take an output middle of two resistor, that give to us 248 value and this is between that values. or I get an output from 3.3 volt that giving 4096 at this time like I press the up buttons or left button. Also, these two analog pins needed to directly connect ground with 10K resistor. As you can see in simple wiring schematic on the screen. Let me show on simple wiring schematic. Exactly like this. I create this simple gamepad for try to set up. Let's continue with flashing. Firstly, we are need a firmware. For getting this, go to the RetroGo repository. Navigate the releases page. Find the ESP32 kit firmware and download it. Then go to this repository and download the firmware flasher tools for your OS. When it downloaded, extract the files and open it. Plug your ESP32-S3 development board to PC. Select your downloaded firmware and select your COM port of ESP32 board. You can see an image file directly. Click that area and change expect file format. Then click the flash ESP button and will be patient. It will take a while. When it's done, you see this info. Then if your board didn't automatically reboot, press the reset button on your board. Last part is SD card prepare. You need to prepare SD card like system weight. First step is SD card formatting. Plug the card your PC. Click right and press format. Be sure that in FAT32 formatted. And then open SD card root folder. Create a new folder name is ROMs. Enter in, again create a new folder, then give it a name NES. Also create a folder which you want to play under ROMs folder, like you see on the screen. After that, copy game files to folders. You see on the display supported console system. Yes, you can play Doom on RetroGo. I don't understand why developers like that game so much. Legally issue, I can't share with you ROM files, but you can find on internet easily. Also Doom is open source. When in any system, it says to you which file extension is supported and how you gonna place it. Then that's all. I showed to you easiest way to make this console. I hope you made it. Probably this episode be the last emulator tutorial I have made. I start to build an emulator for learning something about handheld game console. For now I learned too much thing. For a long time I am working on completely own handheld game console system. I'm ready for this. I hope as soon as possible I published. I hope you like it that tutorial. All you need, links are description. Write in comment what do you want to see in next episode. Your support is important. Like and share this video. Don't forget to subscribe my channel. Hit that hype button. Until next time, bye.